Hi, in this video, I will be showing you problem number 13 of chapter 4, section 8 from the practice exam. Consider the following equation. 3x to the power of 4 minus 8x cube plus 7 equal to 0 on the closed interval 0 through 3. Explain how we know that the given equation must have a root in the given interval. Use Newton's method to approximate the root correct to 6 decimal places. So compared to the earlier problem, the problem doesn't have the first root given to us. So we need to find out first, we need to prove that the equation must have a root between 2 and 3. This can be done by Intermediate Value Theorem. So we take the function f of x, which is 3x to the power 4 minus 8x cubed plus 7, and then we will plug in 2, the endpoints of the intervals, 2 and 3, and then we'll look at the sign of these values, f at 2, so x is replaced by 2 in the given equation, given function, and then x is replaced by 3 in the given function. So one is giving us negative sign, then the other one is giving us a positive sign. One is negative 9. F at 2 is negative 9, which is negative. Then F at 3 is 34, which is positive. F of x being a continuous function and also it's a polynomial, it has to pass through 0 between negative 9 and 34. One is positive and one is negative and one is positive. So between 2 and 3, the graph must cross the x-axis. So there is a root between 2 and 3. So there is a point C between 2 and 3, at which f of c equal to 0. So there is a root between, so in other words, there is a root between 2 and 3. So if there is a continuous function and if f of a is negative and f of a is positive, or between a and b the sign changes, then the continuous function has to pass through a point at which f of c becomes 0, or in other words, it has to cross the x-axis at least at one point. So that is the root of the equation. So that way we establish that there must have a root in the given interval. The next part, to use the Newton's method to approximate. So this is the first part of the problem, and the second part, we have to assume the first approximation. Because the root lies between 2 and 3, we can take the first approximation to be somewhere between 2 and 3, which is 2.5. Then the rest of the roots can be done in the graphing calculator the way it was shown in the previous problem, using the Newton's formula or Newton's method to find out the approximated root. So it is xn plus 1 is xn minus the value of the function at xn and the value of the derivative at xn. We can use this formula to find out the rest of the approximations. As we did in the previous problem, we used the graphing utility for determining the approximated root. Let's plug in the function, given function as 3x to the power 4 minus 8x cubed plus 7 into y1. Then in y2, you plug in the derivative of f of x. The derivative of f of x would be 12x cubed minus 24x squared plus 0. So if we differentiate this polynomial, that's what goes into y2. Then in the line y3, you use x minus y1 divided by y2. So y1 is f of x, y2 is derivative of f of x. And then we are going to use only y3 to evaluate the approximations. So now you go to the home screen and pull up y3 by hitting, actually I can show this again. So hit VAR, YVAR, then 1, and then 3, because that will give us y3. Then in this one, we have chosen 2.5 as our first approximation. So plug in 2.5, hit enter. What you get is the second approximation, that is equal to 2.52166. There are 4, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 7, right? So this is our x2. Then you take y3 and plug in the previous answer to get x3. That will be our next approximation. So hit VAR and YVAR, then 1 function. In that function, we don't need y1, we need y3. So hit 3. Then you plug in the previous answer, which is x2. The previous answer is the second approximation. So in order to do that, you hit second and the negative button. That will give us the answer that will pick the answer from the previous step. Now you hit the enter. What you get now is the third approximation, which is 2.521041882. And then now you do the same thing. Now you hit the enter. That will give us the next approximation, which is x4. So now we have to do this till we get 2 approximations which agree on 8 places of decimals. So if this is 2.521041352. Only the last 3 digits change from the previous approximation. Hit one more time enter. So now you notice that this line and the previous line are one and the same. So x5 is actually the same, 521041352. Now we notice that these two approximations are one and the same up to 8 places of decimals. So the approximated root is x4 or x5, both are approximately equal, which is 2.5210441, because we are asked to find out only up to 6 decimal places, so we can leave it like this. Hope this video helps.